Here we go. So, welcome to the MikroTik user meeting here in Vienna this year. It's my pleasure to present for you again. And this year I'm going to talk about monitoring and debugging with RouterOS. Here's the agenda of the presentation. I'll give you a brief company introduction. Want to show the big picture of network operation, talk about typical management approaches, and then show you a few examples on how you can efficiently use RouterOS for network debugging, and in the last part, how to debug problems on your RouterOS device. FMS Internetservice is a value-added distributor focusing on ISP customers and wireless transmission equipment. Value-added means we are not only distributing, but we are also offering training, consulting, and support. The company was founded in the late 90s, and by today we have 11 employees and are situated in the southern part of Germany, right next to the Swiss or the French border. We have an in-house training facility fitting up to 50 people, and we're proud to do all certification levels for MikroTik since many years. Actually, we're certified trainers since 2007. We've been the first German-speaking training partner of MikroTik with international or early international trainer numbers of 11 and 23. And we're also the first MTCSA certified MikroTik distributor. So we really care a lot to not only sell devices, but also offer the needed information and consulting services so our customers can choose properly. You're very welcome to drop by our distributor table here in the exhibition area. We brought various solutions with us, for example, brand new 10G links from Softechnica, and not the typical maybe, but an upcoming and interesting product range, wireless LoRaWAN IoT solutions from Softechnica. And we'll see an application later on where management is pretty important for the upcoming IoT world. So why did I actually choose to speak about management today? As I said, we're doing a lot of services for customers. We're also running service contracts. And through the last couple of years, we see that operation is getting more and more of a challenge for even small networks. I think the reason for that is that we see growing number of devices in every type of network. We have to deploy more critical services in IP networks, and we have higher bandwidth, and this is resulting in higher amount of packets. So when you have to analyze something, you're really in a problem as there's so much data to look at. And there's also more and more heavy interconnection of sites, that is even retail stores suddenly have hundreds of sites connected to VPNs. So the bottom line is networks are becoming larger, and they're becoming more complex, and at the same time you as IT professionals are required to offer in high availability and high security. The operational tasks involved in management, or the tasks involved in operation, are inventory, that is stock keeping, to know what devices you really rolled out in a network. Obviously, you have to manage them, that is, you do the first configuration, and then you have to manage them constantly if demands of your customer changes. You have to take care for maintenance, that is, taking backups, doing restores, looking for proper firmware upgrades, all this housekeeping work. You have to monitor your devices so you know, are they doing what they're supposed to do? Are there upcoming bottlenecks? Are they failing? And if they are, you have to do debugging for your network. So it's quite a lot of tasks, and you can break it down to more and more tasks. And luckily, RouterOS is offering you a huge set of smaller and larger tools that will help you with operation. And I don't want to go through all these tools today. I'm just having two slides to show them to you. So if you're interested, you can have a look at the presentation later on. And I'm sure most of you will know most of the management tools that there are. But on the other hand, I'm also sure that you will find new things that you've never played with and that might be worth to look at. For example, there's TRR69, which is a provisioning protocol from the ISP world. It's not been in RouterOS too long, and there is a presentation later on today from one of my colleagues, no, not from our company, but from one of my MikroTik colleagues. It will probably be really interesting to look at. And there are even more tools that you can check out. If you don't know Torch, for example, it's really worth a look at, but it's not going to be looked at in this presentation. Or there are not that obvious things to do, like port mirroring with a switch chip and sending traffic to an intrusion detection system like Snort, for example. So MikroTik is offering you the complete range of smaller and larger tools that help you with operating your network. When we talk about operation, the first thing you have to decide about is what management topology are you going to choose. Management has to be secure and convenient at the same time, and things are never secure and convenient at the same time. You usually get either or, so you have to take your own decision. And next to that, a management topology needs to be efficient so that your staff or yourself can react fastly if there are any problems to solve them. And all common management approaches are based on the same idea. You separate management from user traffic, so you don't even let the wrong people access the management interfaces of your devices. This could be management VLANs, for example, or tunneling payload, like tunneling user traffic across an ISP's backbone by using PPPoE. This is a very common approach. Or the other way around, by tunneling your management traffic through a userland network and using VPN to tunnel the management. I just want to point out shortly that there are a few central tools from MikroTik that should be named when you're talking about management. That's the Dude, the NMS system. That's Caps Manager, the Wi-Fi controller. And Caps Manager actually implements an automatic management topology by building UDP tunnels between the access points and the manager. And we should name User Manager, which is not really a management tool by itself, but User Manager can, as a radius implementation, can administer user accounts for your routers, so it can help with centralized management. Detailed examples that I want to look into together with you are Roamon and MikroTik's API, the application programming interface. Roamon is all about simplifying discovery and access. It's the router management overlay network, and that's actually what it does. It's building a dynamic management network as an overlay of the existing physical network. It's a proprietary MikroTik protocol, and it will help you with device discovery and accessing your devices. As it's using an overlay network, it's independent of the existing layer 2 or layer 3 network. And that's pretty important, as it's not going to be blocked by routers or layer 3 boundaries. And it's, of course, working without layer 3 routing being in place, as it's using its own overlay network. Roamon does also have direct Winbox support. So when you see discovery and access and Winbox support, there will probably be something else you're thinking about, and that's MNDP. I guess everybody is using MNDP in Winbox in his daily work. But how is MNDP different from Roamon? Well, MNDP is using an existing network, so it relies on your bridging and routing configuration. It will not cross routing boundaries anyway, and it could be firewalled. Roamon is creating its own overlay network. MNDP is compatible with a CDP, Cisco Discovery Protocol, and LLDP, while Roamon is a proprietary MikroTik solution only compatible with other RouterOS devices. As I already said, MNDP is limited to the layer 2 broadcast domain, and it's offering discovery and MAC-based access within Winbox. Roamon, in contrast to that, is not limited to layer 2 domains, and it's also offering discovery, but Roamon discovery and Roamon-based access through an agent into Winbox. And to make it complete, Roamon is only working on Ethernet-like interfaces, like Ethernet, of course, Wi-Fi interfaces, Ethernet over IP, or VLANs. Here's an example how you could use Roamon for managing your local network. Imagine you're administrator's workstation at the very left-hand side. You have 2 routers and 3 IP subnets. And on the bottom left corner, you can see a bracket that will show you how far standard MNDP discovery will get you. It will show 1 router and 2 access points, as these are within your layer 2 broadcast domain. Roman, in contrast to that, that's the blue bracket at the top, will allow you to discover and access all devices in your network, although there are routers in between. You will simply connect to any of these devices, and then you will use them as an agent and see their network. This is particularly useful if you have to access something at the other end of your company. And today, with standard MNDP, you would have to go to the last router, use its neighbor discovery to discover these devices. But with Roman, you can get them all in one list. It's pretty easy to set it up. All you have to do is go to Tools Roman and enable the checkbox. That will already make Roman available on your router. But there are 2 optional but really recommended settings to take. The first one is to set the Roman ID manually. If you don't do so, the router will simply take one of its MAC addresses as an ID. But as you know, the MAC address can change if it's related to a dynamic interface or virtual interface. So for example, a bridge MAC address or the MAC address of a tunnel. If you saved such a MAC address in your Winbox as a bookmark and the Roman ID changes or the MAC address changes, the bookmark is simply not working anymore. So it's a better habit to use, for example, the Ethernet 1's physical MAC address as in Roman ID. I'd also suggest you to use a secret, because if you don't use a secret, your Roman information will be simply spread as far as there are Roman devices reachable, and a secret will build some weak sort of security, but it will mainly help you to do things wrong and to spread information further than you want to spread it. And there's an optional configuration that might be necessary in some topologies, that is to set up additional Roman ports. By default, you have 1 rule allowing Roman on all interfaces, but you can forbid it on separate interfaces if you add other ports. And we'll see an example for that in a few slides. So once you're connected to the Roman network, you're able to run Roman-capable tools, and that's Discovery, Ping, SSH, and Winbox, of course. And Winbox is the only tool that is offering MNDP and Roman at the same time. For the other tools, you have to use the correct Roman implementation. For example, you can receive access Discovery and Ping from the Roman window, as you can see here on these screenshots, while SSH has to be accessed by the CLI. It's not directly integrated in Winbox user interface. Here's a screenshot to make that point clear. You have a standard ping at the left-hand side pinging a MAC address, and on the right-hand side the Roman ping pinging the same MAC address but as a Roman ID. And while MAC ping will not get through, since there's a router in between, Roman is perfectly working across the complete network. This Winbox screenshots refers to the network diagram that I showed you earlier. So there was the manager's workstation at the very left-hand side. And if we do enable discovery in Winbox, we will do it from the current laptop. So we see the laptop's view of the network, and MNDP is not crossing the first router. So in figure 1, you can see that it shows the next router and the 2 access points in the same layer 2 subnet. And in figure 2, you can see that you can connect to a Roman network within Winbox. And here we connect to the first router, but it could be any other device in the network. It wouldn't make any difference. So after you're using this router as a Roman agent, in figure 3, you can see that by now you're not seeing the local view of the manager's laptop, but you can see the view of the Roman router. And this router is able to discover all the other devices in the network. As you see in figure 4, both routers and all 6 access points can be discovered. And that red line in the Roman neighbors is showing the last access point in the network, and you can see that there is a path with 2 hops to access this access point through Roman. So this is what you see here. We use router number R1 as the Roman agent, and at the bottom, at figure number 1 and 2, you can see the two Roman IDs that the path to the access point A32 consists of. So that way, I think the point is clear. Roman will give you great insight to your complete local network. But you can connect to Roman agents also by IP address, so across any layer 3 network, for example, the internet. And that's even more powerful feature, as you can do remote discovery and management. So no matter if you're managing branch offices of a company or if you're managing your customer networks, remote Roman will give you complete insight in their inventory, at least if Roman's enabled. So here's the network diagram to it. The operator can connect, for example, to customer router number 1 through the internet. By that time, this router is acting as the Roman agent and showing him the complete local network of that customer. If you do that, please make sure you're disabling Roman on the WAN interfaces, so you're not exchanging Roman information to your internet service provider. That's what you see in the bottom left corner. Simply forbid the uplink interface. In this case, it's Ethernet 5. So regarding security considerations, I already said disable Roman on the WAN interface. I would strongly suggest to also disable Winbox on your WAN interfaces. We've seen problems throughout the complete last year of hacking and break-in attempts to Winbox ports, so there's really no point in having them open. And what we've seen earlier, simply apply a decent management topology, and that would mean separate your management from your user traffic. So in this case, for example, use a VPN to connect your customer routers. Then you can use Winbox through the VPN tunnel, have the first router as your Roman agent, and then start using Roman to access all the devices in your customer's network without routing or any other prerequisite to be in place. Of course, you could also combine that with a management VLAN at your customer site. So at the end of the day, it's always a combination of different means to achieve a good management network. So the next example that I want to give you for management is MikroTik's API. It might not seem very obvious where the API is related to management, but actually the API, the application programming interface, that is the possibility to remote control all the features of your routers by common programming or scripting language, is an extremely powerful solution. You will see different vendors here in the exhibition area who are offering their multi-device configuration tools that will help you to have MikroTik projects in an environment where it wouldn't be possible without central management. And I want to give you a simple project and requirement that we had from a customer and that we solved with a custom-tailored management access solution based on the API. This was a consulting customer, so MikroTik wasn't set as the solution. We were simply asked to find a solution for his situation. He was running a countrywide hotspot system with hundreds of sites, and he had to deploy new gateways for different reasons. There were 100+ third-party devices on each site, and they all had locally fixed IP4 addresses, and they were using the same subnets on each site. So we had to do central management, but we had conflicting IP subnets. The customer was running 2 small NOCs and a few road warriors, so he wanted his staff to have access to his installation too. His initial requirements were an easy operation when he was creating new customers himself, and that included an automatic configuration of the internet gateways at his customer sites. And he also requested the third-party devices that he was not going to change to be directly accessible from a central management interface. He wanted to have central inventory and central monitoring with dependencies, meaning if a main router is failing, he didn't want to get 150 alerts for the access points behind this router. So the solution we came up with was to use MikroTik as a gateway router and to use the API to create a relatively simple central management application, because all this application had to do was using the great amount of features that we already have on our routers. Here's just a screenshot of the application, and here's the network diagram of that customer. Figure 1, you can see the NOCs and the road warriors. Figure 2 is showing the complete data center with a third-party captive portal, but mainly with his RouterOS-based VPN access concentrator and our management platform, which is basically a web server running a few API-based scripts with a web interface. And figure 3 shows the customer sites. So these were a couple hundreds of sites, each one consisting of a MikroTik gateway and third-party access points. The first requirement was his stuff should be able to add new sites, new customers, without having deep knowledge of any special technology. So this is pretty simple to be fulfilled. We had a database application letting him insert a new site and simply created a dynamic configuration for his site routers. That's the last router on the right-hand side, the yellow one. And it's fairly easy to import this application without additional knowledge into your router. But at the same time, we were using the API to create the other end of the VPN connection on the VPN access concentrator. So that's actually everything there was to do to let them manage new sites. And it was a bit more complicated to let them add new devices, as these were third-party devices with fixed IP addresses, so they were in place already or configured by the end customer, and they wanted central access and monitoring of these devices. Central access is a bit of a problem if you have lots of same IP addresses and you want to access them centrally, but the solution is pretty simple by using destination NAT. And all we did is having the central application use the API to create dedicated destination NAT rules on the gateways of the customer sites and offered within the web interface links written like endpoint colon device port. So that way the NOC team was able to access thousands of devices with conflicting IP addresses. Monitoring was a little bit more complicated since we cannot simply port forward ICMP packets. So that way we were again using the API. Monitoring is done by the central web server sending API requests to the site routers. These site routers monitor the local devices by ICMP and simply return the result by API. So as you can see, all in all, it's not a big deal. And the API will enable you to create even very custom-tailored management solutions, like in this case, and it doesn't really take much of an effort to do so. So my suggestion is, if you have projects that are lacking central management, and we find such projects more and more often, take a look at the API, and it will probably give you a solution. And there's one special case that is getting more important commercially, that's IoT or management of like machines, for example. More and more vendors are starting to create management solutions for their machines. We have projects with worldwide deployment of CNC machines, for example, where the vendor simply needs access to the machine. And although this is a typical network on one hand, there is a big difference since this network is only being created for management. So it's not a network and you have to management, it's the other way around. The only purpose of this network is management of something. And that means typically you have really small but a lot of sites. And there is a lack of trained staff as these CNC machines, for example, are rolled out through the complete world and there's no local staff to help the vendors with. So in such an environment, you really need an efficient and simple application that lets such a vendor manage thousands of VPN connections, deploy rule-based firewalls, and stuff like that. They typically decide of a topology at the beginning, and then it will be your task to make it possible. And we see such projects in IoT, for example. There's another example here, the top right corner. It's was smart metering of transformer stations, of hundreds of stations that came with the very same requirements. So at the end, it will always be simplified central management that such customers require, and it's great to know that you can provide that by having your own API applications. So now let's go into something more practical, that's network debugging. And as I said before, one of the challenges of networks today are that they're constantly getting bigger, more devices, more packets, more bandwidth. So solving a problem is really looking for a needle in a very huge haystack. And if it's getting complicated, the last resort typically is sniffing the packets in the network. That can help with planning firewall settings, detecting network problems, or even solving problems on a higher layer like client-server applications. So if something's really going wrong, you need real insight, and the de facto standard for packet sniffing will be Wireshark, which is a free application that probably most of you know. And there's also a packet sniffing implementation in RouterOS. It's easy to set up. You define a couple of filters. What are you actually going to sniff? Source IPs, port numbers, etc. Hit start, stop, and if you want, you can see the results in the Winbox interface later on. But honestly, packet sniffing is a complicated task anyway, and it's not much fun to see the results in your router's interface. So the next step would be to have your router write the packet sniffer results into a file. As you can see here in the screenshot, we are writing a file called sniffer. And later on, you can take that file to your computer for offline analysis in Wireshark. So this file is compatible with Wireshark. But there's even a more decent way to do so, and that's a really powerful debugging application. That's streaming your packet sniff to Wireshark live. And that's what we're going to see here. This is an example setup. You could sit in your office somewhere, and all you need is the router at the very end in your customer's network to have IP access to your notebook, because you want him to stream the local packets to your sniffer. And to actually do this, you have to enable streaming in the packet sniffer, and you have to give your notebook's IP, since it has to know where to send the packet stream, and you should definitely check the box that filter stream, because if you don't do so, the packets of your stream will be sent in the stream again, and you will create an information loop, and your router will go to 100% CPU instantly. But if you hit filter stream, this is not going to happen. You will just see all the packets but the stream packets, and this is going to be sent as a TSAT-SP stream to your Wireshark device. And in Wireshark itself, you want to make sure that you're just seeing the encapsulated packets from the stream and not local traffic. So you create a filter rule there, what you can see at figure 2. So you filter for UDP port 37008. That's where the stream is being received on that UDP port. And if you do that and start sniffing and choose the correct interface in Wireshark, you will only see remote packets from the remote router. So you have a really powerful, totally free, remote sniffing application in real time. This is how the result may look in Wireshark. In figure 1, you can see that we are capturing from the Ethernet interface and are filtering on that UDP port. And on the bottom, you can see that this is a live sniff. So this is not offline, but this is live. And in the middle, just for the fun of it, you see all these protocols that we've talked about before, MNDP, LLDP, CDP, and at the very top with number 88BF, this is Roman. So right here you can see what a great insight Wireshark will give you. If you don't want to dig that deep, but if you want to stay at an easier level, or if you're looking for different problems, there's another great facility in RouterOS that's called Traffic Flow. Traffic Flow is giving you statistical information about your network. So where Wireshark is really analyzing every single packet, traffic flow is giving you condensed information. Traffic flow is compatible with NetFlow. NetFlow is, I believe, Cisco invented protocol supported by many applications. And traffic flow is giving you statistical information about packets and packet counters, but mainly source and destination IP addresses and protocols. And it is an easy way, for example, to find top talkers in your network. And that would be fairly difficult by any other facility. Of course, SNMP is giving you interface counters, but it would be quite exhausting to find the top talkers or the top ports in your network traffic by using SNMP or by using logging with firewall rules or counters or whatsoever. So traffic flow is just answering a few questions, but it's answering these questions really efficiently. NTOP used to be the open source, free standard application for NetFlow processing. Its successor, NTOP NG, is more commercially oriented, and it's a bit sad that it doesn't support NetFlow streams anymore. So if you want to use NetFlow streams in NTOP NG, you have to buy a commercial probe called nprobe, and that's basically why we are not using it that much anymore. The screenshot you can see here is from the old NTOP application. There are quite a few freely available alternative applications, collectors and analysis applications that support NetFlow. And we implemented one of them in our internal management platform. And this is a screenshot of an NTOP dashboard. I believe you can't really see much of it. Let me check. Okay, but maybe you can read it now. So here you see top talkers in your network, for example, by IP address, or top talkers, or top port numbers, or top protocols. So this is what NetFlow is good in answering. It's not pretty good in giving you different information, but as I said, there are some questions where NetFlow is pretty strong in. The last part of the presentation is about debugging problems based on your router. Of course, your router is part of the network, so a network problem could also debugged on the router. And it's the same situation here. More packets, more services, more complex. So another huge haystack with lots of information. And as I just said, if you're debugging from the view of the network, you will look at packets and packet statistics. But if you're debugging from the view of your router, you're working with local information, local status information. And of course, there are two things coming in mind. One is SNMP. But I don't want to talk about SNMP too much here now, but I want to show you how powerful local logging can be. Personally, I believe local logging is one of the most underestimated features in RouterOS, or not only in RouterOS, altogether in network debugging, since it can answer so many questions, but it takes some extra mile to go to get decent information from it. The first thing you actually have to do is you have to implement a central syslog server that is collecting the logging messages of all your devices in the network. There are a few reasons why this is a good idea. At first, logging information will survive reboots and crashes, and you don't have to write them to your local hard disk. There's also a security reason to do so, since these messages will be more tampering proof. That is, if somebody is hacking your router, he will not automatically be able to delete logging informations. Then, of course, external applications will allow you a far better searching as they are more powerful, and it's up to you to implement the interface in a way you like it to be. And last but not least, it's the only possibility to have you do correlations between the logging messages of different devices. Imagine this simple example here on the right-hand side. You have two VRRP routers, so maybe a larger VRRP cluster, and an RSTP ring with a bunch of switches, which is interconnecting the cluster routers. And now you want to find out why the VRRP state of an interface changed. This could have so many reasons. It could be the reason in VRRP configuration, in RSTP problems, in single devices rebooting. And you're not going to find the answer to it if you're not digging into the log files of all of these routers. And this is a perfect example for using central syslog with a central search and correlation across devices. To send your information to the syslog, you have to create a new action in logging with the type of remote, and you set the address of your syslog server and the port of your syslog server, and then you carefully choose if you want to have BSD-style syslogging or not. Syslogging is actually such an old facility that it's always a pain to be compatible, as nobody is really following the standards. And changing to BSD syslog will, for example, change the way the time is sent and will also change the way the source is sent. It will suddenly send the router system identity as a source. And having proper time and proper sources is, of course, critical in your database backend. After you created this action, you have to decide which topics this action should be used for, so you're actually sending logging informations. In our management platform, we support syslog, netflow, and SNMP traps at the same time. And we're using publicly available tools like MongoDB, for example, as a database, or Elasticsearch as a powerful search engine. And we also implemented some MikroTik specific add-ons that I'm going to show you right now as the last slides. For example, the MikroTik MIP, or enhanced support or enhanced understanding of the syntax of MikroTik log messages. And this actually is pushing syslogging to, I believe, really a new level. So this is just a short screenshot on how to do central search. You can give a time span, you can use a keyword to search, and you will see the syslog messages through all of your devices. And with such simple searches and by using a mean of visualizing these search results, you can create rather interesting dashboards. This here, for example, is giving you an idea about the number of Wi-Fi connection attempts in your complete network. So it's not showing simultaneous connections to your access points, because this would be a question to ask by SNMP. But this here is showing how many connection attempts are taking place. So it's giving you different information. It will let you understand if Wi-Fi connections are flapping, for example, and on which access points you have the most connections coming and maybe even going. So on the bottom right here, not sure if you can see it, you can easily understand this access point here with 10.10.040 has more than 90% of the Wi-Fi connection attempts in the network. And this is an information you simply cannot get by any other means but by using syslogging. And if you combine this with SNMP in one dashboard, you can get both informations. You can see how many connections do I have and how many connection attempts are there. And then you will understand, are these 10 users, they're creating 1,000 connection attempts, so there's probably something wrong with an access point, and you would get the access point's IP address, and you should take care of it because it's definitely creating flapping Wi-Fi connections. And if you go one step further and make your syslogging engine really understand the contents of the syslog messages, then you will even get more interesting information and you can ask more interesting questions. Here at figure 1, you can see a standard syslog line from your RouterOS. At the beginning, you have the facility, and then we get the log message, login failure for user admin from IP blah, 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 via web. So this is a failed login to the web interface of one of your MikroTik routers. And it contains two interesting parts. It's the username, and it's the facility somebody tried to log in with. And if you use, for example, regular expressions to really draw this information from the log line, and if you create additional fields in your database, as we did here, with these two columns in the database, MikroTik login via and the username, you suddenly can search, sort, and analyze for this information. You cannot just count log messages, but you will get far more powerful dashboards like this here, for example. I try to zoom in a bit to make sure you can see it. Down here, we'll get an information of the usernames and the facilities we saw failed logins. And this is, again, information you cannot get by any other way. This information has to be taken by syslog. And if you make your syslog server understand the RouterOS logging syntax, it's really easy to answer such rather, well, complicated questions and to have graphical representations on them in your logging backend. So, well, I believe this was my last slide. Looks like I'm well in time. I want to thank you for your patience. I hope you got a few. Thanks, and enjoy the rest of the meeting. Bye-bye.